This video is going to take you through graphing a Limacon without a loop. A little easier to draw, not as fancy of a shape. And the key with these is that when you do B minus A, you're going to come out with a negative number. So negative means no loop. Both start with N. Again, you want to know that because 0, 0 is not going to be a critical point there. So just like before with the Limacons and the other cardioids, we have a pi over 2 and negative pi over 2 for the cosine graph as two of your critical points. You'll have a 0 and a pi for the sine. You'll have a plus b. But the difference between the loop and no loop is that you are going to have the b minus a on the opposite side. So what you could do is take your b minus a and just keep it negative. So you can do b minus a 0. It's going to be the same as before, but you're going to have a negative. If you want, you can do it as a minus b and then put it on the opposite side using the theta measure. That's up to you. So just to be careful with graphing, and you don't have to label it this way. You just have to know that a plus b and then b minus a are going to be on opposite sides of your axis. If you want to label the points the same way, you actually can do that. So let's take a look at our first example. Again, if you need to pause to kind of fill in your chart and then keep going, do that. Our first example is, again, a cosine example. This one's a negative this time. If I do b minus a, so 2 minus 3, I get a negative 1. Negative means no loop. So I'm going to put at 3 and negative 3, if you want to look at it that way, dots. For the cosine, I'm not going to put one at 0, 0. It's negative, so I'm going to put one at 5 on the negative side, because the a plus b. And then the b minus a, I'm going to put the 1 on the other side. So I put 5 on our negative side, I'll put 1 on the opposite side. And then graphing-wise, there still is a little bit of an indentation. I always thought these kind of looked like lima beans, so Limacon, lima bean. Kind of an okay connection. Only for the no-loop ones, though. So here, you can write A as 1, 0. B is going to be 3 pi over 2. C is going to be 5 pi. Notice I'm not labeling this the same way as shown above on the chart, but that doesn't really matter as long as you're labeling the points in the right way. So knowing the opposite side stuff is important. And the last example of this type is going to be the sine graph. Again, similar idea when you're coming up with the type of Limacon. Let's take a look at that. We're going to do b minus a. So we get 1 minus 4, we get a negative 3, no loop. So this is a positive graph. We want to put it on the positive y-axis side. When we go to graph a plus b, we're going to put that at 5. We're going to put at 4 and negative 4 other points. And then on the opposite side of where we put the 5, that's where we're going to put 3. So right there. Again, there should be a slight indentation. It doesn't have to be too big. And we'll label these A, B, C, D. And once you graph it, you can label these how you're comfortable with your polar coordinates. Sorry, that should be a 4. So remember, you can do 4 pi, or you could do negative 4, 0 for D. And if you notice, I just put a negative sign back on the pi over 2 for A. You could also do that as negative 3 and pi over 2, if you would want to. Alright, so those are the limacons without the loops. The process is kind of similar. You just have to know where to put your information, depending on if you have a loop or you don't.